We're now entering the Q&A portion. So if all the speakers, panel members could turn on the cameras and be ready to answer questions. First question is for Carly. Would it be useful to have EVA illumination in wavelengths other than visible light, like UV, for astronauts to look into shadowed areas? Would the rocks and minerals in the feldspathic breccias stand out from each other differently in UV or other wavelengths?
That's an interesting question, and it sort of branches into an even broader one. As most people know, I'm a spectroscopist, and I want to measure many wavelengths at once because it gives us a broader picture and can identify individual species. It's hard to identify individual species with one wavelength. But if you could have, say, one of the handheld instruments be a nice little spectrometer where you could zap a point, that would be wonderful. And you could find where the good nuggets of mantle material is in the midst of all this feldspathic breccia. So it intertwines with both the question and the sorts of things that Kelsey was talking about.
Yep. And in a happy coincidence, you're here also as the co-chair of the League ClockSat. And we have a question. Will there also be opportunities for new orbiter-based instruments for detailed mineral surveying?
I would certainly hope so. One of the things the ClockSat is realizing, and Tim, you're on the team, is that even though we have a wealth of data, it's always a taste. And like every bit of information, it opens up new questions and you want additional, whether it's multiple measurements of the same site, whether it's higher resolution, whether it's a different wavelength. All those questions will come out in our ClockSat report. So we're not done yet.
For those who might not be aware, ClockSat is the league. It's a league specific action team for continuous lunar orbital capabilities. So we're looking at options for orbital capabilities essentially after LR. Question from Hunter Williams for everyone. How do the Artemis ConOps integrate robotic sample collection and instrument deployment with astronaut activities to meet science objectives? What are the key ways astronauts are filling gaps that robotic science labs couldn't? Anybody want to take a stab at that?
Well, I'd be glad to take the first part of the question at least. I can say from an ACD perspective, all the activities that we're expecting by the Artemis suite of programs and vehicles, we will include all of those in the mission plans, including the robotic activities. So as an example, the lunar terrain vehicle, we might use that robotically between missions. The objectives would be coordinated with the science community. They'd be well documented. And then the implementation of those would be a cooperative effort among the science teams, the LTV program, and whoever the commercial provider is of the rover. So the bigger picture part of that, as we're building the Artemis mission integration plans for subsequent missions, we would ensure that those robotic plans allow for LTV to show up when and where it's supposed to support the next mission. So we're definitely considering that sort of robotic type in-between activity as part of the overall Artemis mission planning world, if that helps.
It does help. But I actually had maybe a related question, maybe a different question, and maybe this goes to Sam best. So the Decadal Survey had a study for the Endurance A long traverse rover mission, which would collect samples and potentially bring those back for astronauts to carry back to Earth. How do you see Artemis science objectives or the process of achieving those science objectives changing to if Endurance A moves forward?
The answer is that the agency is still digesting the decadal survey, so I'm going to sidestep your question and answer a different question that's addressed by the Science Definition Team report. So if you read Chapter 4 of the SDT report, It pretty explicitly calls out that that NASA is aware that the community is after global access, and we like to collect samples from a diverse array of terrains that don't necessarily just encompass the polar regions. So I think everyone's sort of aware of the interplay between the community desirements and things, you know, expressed in the Lunar Exploration Roadmap and the various other trade considerations that go into architectures, right? So if you build a base at the lunar pole, then you may think that you're, you know, tied to one location. But if you build a base at the lunar pole and you have infrastructure that enables you to do long duration rovers like Endurance A or other, you know, other assets that may or may not ever happen, but are at least being considered, or things like hoppers, or things like leveraging local resources to, you know, provide additional mobility or additional capabilities. I think we're going to get into a very interesting future where you're no longer necessarily constrained by this very sort of um, Apollo-style mission concepts, and you have this full continuum of capabilities on the surface, whether it's pressurized rovers or unpressurized rovers, or astronauts with advanced analytical instrumentation in a surface habitat, or astronauts carrying instruments. You're going to get this amazing continuum of capabilities that's very similar to what we do at McMurdo Station. And I don't think the community has really grappled with that yet. I think we're so used to living in this very sort of Apollo mindset that we haven't really had the luxury of contemplating the future that could be, and is very possible at this point. It's certainly within the realm of possible. So a lot of those concepts are actually sketched out in chapter 4 of the science definition team report, sort of the long-term vision. So that'd be kind of my answer to you, is that the SDT report calls it out explicitly, and I think I'm personally very excited by the possibilities that could bring to us.
Thanks, Sam. We have a question and a comment, both related to tool and sample mass. Jeff Plesha points out there's going to have to be a trade between return sample mass and the mass of various instruments and tools optimized. Somewhat relatedly, John Gruner has a question for Tim. Does NASA have cargo mass available for the uncrewed SpaceX landing? Will that uncrewed landing occur near the South Pole?
Okay, thanks for the question. And for the first part, SpaceX is not currently under contract to deliver any NASA cargo to the lunar surface for that uncrewed demo mission. We are in the process of discussing that, though. And as part of that process, we want to see what capabilities are available on that vehicle, what's the feasibility of putting utilization cargo there, what opportunities might there be. But that would be something we'd have to discuss with SpaceX and work to get those requirements into their contract. So that's work that's ongoing, and we don't have a resolution to that yet, but it's definitely a possibility. As far as the second part of the question about whether the uncrewed landing occurs near the South Pole, I'm not 100% certain what has been publicly released about that, so I can't comment on that at this time.
Thanks, Tim. Melissa Lane, question for everyone, but I think this is related to some of the material Kelsey was presenting about robot human interaction. Could there be something like a small pull-along wagon type helper, or mini robotic wagon to carry instruments that might fall somewhere in between the heavy, lander mounted or in the much lighter astronaut mounted or handheld, instruments?
Yeah, and I think that trade space is interesting, because I think in addition to that, I totally agree with Melissa's points, and I would also add potentially some sort of like tool caddy or something as well. I know that the EVA tools team has presented their work on that in the past, and now that we have XEVAS coming online, we'll have to stay tuned for what the provider of those geologic tools will want to provide. But I think that's a similar idea of something the astronauts would hold or drag behind them, or it would follow behind them, that would carry stuff, so like samples, tools, payloads, etc. I think for the like 6 sort of categories of things that I presented, that's almost like 6A or something, sort of a hybrid between the walking stick and the rover mounted, right? There's like sort of a spectrum in there. It's perhaps not an A member, but more of a spectrum. And I think you're right. I think we could have done a better job of elucidating that sort of extra use case. But those types of that type of hardware is under evaluation for the Artemis architecture.
Yep, great. And I think we have time for one more quick question. There's a couple other comments in the chat, but maybe a question from Jim Skinner. Can someone comment on how Crew and MCC will locate themselves accurately in the field?
I can take a stab. That is a hot topic right now, navigation and how exactly what you just said, how the crew will be able to locate themselves, how MCC will be able to, keep tabs on where they're at. There are a lot of trades that are being considered right now, and actually some of the NASA test events that are going on this year are specifically designed to tackle that navigation question. So I don't have a great answer for you other than it's being like hotly worked on right now.
I want to thank all of our panelists very much. This was a great opening session. It really kind of sets the stage for our discussions a little bit later. And for now, we're going to go on a 15-minute break before we start up the early afternoon session. So thank you again. Really appreciate all your input and thoughtful presentations.